Right, hello folks, 8:30 in the morning. Let's see whether we can make a start on the second set of Alan's, because he mentions in his letter about modification. So, I don't know, does that mean it's an 80 channeled set? In which case, of course, that's got to come out as he says. I would like to find, one day, I'd like to find a set that's been illegally 80 channeled and actually run a test, because I've never known one work. The modification usually ends up in culminating, the combination of which tends to be the phase lock loop chip is killed. So, legality aside, I'd like to see one work, just so I can say categorically how dreadfully the set then works, because that's what's going to happen. Right, well, we'll open it up. Didn't see Mr. Chippy yesterday, so we didn't get the previous set done with an on-the-air test. So we might have 3 on-the-air tests stacked up for today. If I can get this fixed, I'd like this to get back to him tomorrow. Right, are we ready? Well, I can't see anything. Ah. Right, so what's that become? Oh dear, yes, so it's got a trimmer capacitor there. I wonder if, and that goes to the crystal, I wonder if this is one of these sets which does a channel -1. But of course, the whole reason you can't do this, legality aside once again, is if you change the reference crystal frequency, it's going to change the IF, the intermediate frequencies, which are generated by the same arrangement. So your receive is going to go through the window. Perhaps nobody wants any decent performance. It's all for the novelty. So he's right, it's modified, but it's not 80 channeled. I think it's a -1, or between the channels, or something equally ridiculous. Right, so plug the test gear in, and you know what, we're going to have to plug power in, aren't we? We did send a mic with it, but we'll use it on our test thing. I wonder if we bought this off eBay as a perfect working set. Okay, let's go straight to the frequency counter. Picture in picture on, and let's find the frequency camera. Frequency camera, yeah. It's camera 2. Transmit. Well, I nearly swore there. It's doing just over 5 watts. So it's been, what will have happened here is that some numpty has set this into service mode where you get it to the peak and then you drop it to balance it, and someone's left it in the peak just to get that extra power, which doesn't give them any better range, but presumably in order to kill the set. We'll just test this motor car, but we'll run it round on full revs and achieve the speed we want by slipping the clutch. He says driving manual cars in UK. Right, I don't even want to run it at that power. I'm going to run it at 12 volts instead of 13.8, so we're not killing it. It's now doing 4.1 watt, which is a bit safer, and it won't affect the frequency. So let's have a look. So we should be on 27,79125. So that is a pretty normal off frequency, needs adjustment. That sounds normal enough. So one of these switches, when we're not shorting out the power supply, this one on the left, which says tone high low, looks like it changes the reference crystal. Yeah. So what does this one do? Or is this still working? I think that switch is still doing what it's supposed to do. It just doesn't work on low power. Going to touch the preset. So when we go through this, low power was 0. Just see whether I can get it to work to just prove what they've done with the switches. Yeah. It was actually set up wrongly more than... So it was 0. So we've got tone control, tone switch, modified for illegal operation, probably between channels. So what we're going to do is we're going to look at, I'm just not going to run it at full power because it's going to I don't want to kill the set. I don't want to add 16 quid's worth of parts onto his bill. The fact it's modified puts it into our service level 3. So what we're going to do, we're going to put it into its normal state on channel 20. Let's just see where we are. Yeah, so put it into its normal state, and I'm going to see what the deviation is. Wallow. Now, that I can't tell because I think I'm going to switch the other test set on. Give that 10 minutes to warm up. let's have a look at how the receiver's doing, just as it is. 27, and because it's slightly off frequency, we'll take that into consideration. Was it 100? Let's go back to transmit. 2779088. That'll do. And we can already hear that at 0.3 of a microvolt. So I'm going to put it onto the Cybernet meter. It's actually fine. So at the moment, let's just turn the volume up a bit more. It's 0.46. Not 0.43. And then if it does that, it's 0.96. Squelch is 100 microvolts, exactly as it should be. And the sensitivity is a very good 0.48. S9, let's put 100 microvolts on. We're on the 300 scale. No, we're not. We're on the 1 millivolt scale. Is 420 microvolts. That's a very lazy meter. Do these have PA? No. On transmit, I can't do transmit because it's over the top. So now if I flick the silly switch, it goes off frequency. Right, back to transmit. I'm going to now put the set on frequency. It's had some not so good soldering around here, which we'll clean up. Right, here goes. Transmit. Show the right thing. There we go. So put it on frequency 79125. In fact, this is going to change when we take the modification out. But I want to see with the modification what they're trying to achieve, and I think it's between the channel. So 79125. Flick the naughty switch. And it's 796. It's kind of 0.5. It's kind of between the channels, isn't it? Absolutely bizarre. And you can tell by the tape it's been there an awful long time. We're going to have to take the front off this to do this properly. You know, when you see these videos, you know, if it's pretty straightforward, our video is going to be 35-40 minutes, and if it's quite complex, it's usually going to be an hour and 2 minutes or something. But I might have spent hours and hours on the set. You know, I do actually have to edit the tapes. I don't think they are tapes, but you know what I mean. Suit me if they were. Yeah, I could do it on pneumatic if you want me to do it on pneumatic. Now on these sets, I mean, otherwise it's in reasonable condition for a 40-year-old set. Oh. That's going to be the piece of string method or something. We do have some plastic pullers as well, kindly sent in by a viewer. You know what, I haven't got those with me. I haven't got a piece of string with me. I've got a piece of wire with me. Good grief. That's going to, I'm going to have to prize this one because but I can do it in such a way that nothing's marred. In fact, it really didn't need much touching. Right. Now the trouble with these is the mic socket. You've just got to unsolder the capacitors so we've got a bit more leeway. And hopefully we've just got enough wire to kind of pull it to one side. Just like that. And what we're going to do... What on earth's that? Oh, it's one of those capacitors. I'm going to take this. These are the little shrouds. We'll take those off. Take the switch out. Loose the screw inside the set. Which fell out onto the bench and then onto the floor. So again, this will have to be cleaned up with isopropyl alcohol. I think that's it. So there we go. So we've got to put a new capacitor on there and research what that capacitor is. Right, so I'm going to take the opportunity. We'll take the power off. We've got the switch. I'll take the opportunity to clean the affected area of the board. didn't even... What flux have they used? Just do that as well. So your channel selector switch is soldered to the data lines of the phase lock loop chip this side, and this end is solely the display, and it looks like they've been having some iffy display problems at some time. So just go over this as well. Then at least I can inspect it through all the burnt flux. Let's just hope they haven't cracked any of these cores. I'm going to have to peak this at 12 volts and then do this at 13.8, because I really do not want to run this at that kind of power level for more than about 8 seconds. So these are our wires which would have gone to the I thought the capacitor was just on the board, so we're going to have to open up another York 861. And I think there's one on the shelf of my own waiting to be done. A couple of hours later, we've had a look inside this set. So I'll put the lids back on it. So I could say it's taken 1 hour to do what I've just done to get the information to restore this switch back to being a tone control. Put that to one side. So taking a photo inside that radio, which shows we've got the blue wire and the black wire and they go to the middle contact. So there's the blue wire and the black wire. So hopefully there's enough still. I reckon so. So it isn't going to matter which wire goes to which. But the black wire goes towards the display board in the sample I've just looked at. So the black wire towards the display board, and the center contact, and the blue wire so that's why we needed that. So now we've got that the same way on, and the capacitor goes across the top too. So what's the capacitor? Well, that's where we need to look at the circuit diagram. Now this book, Servicing UK CB Radio by Michael Tooley, very, very good book with all the correct methods of doing tests. It is the real thing. It has some circuit diagrams in the back. The York 861, which I don't have a manual for, the circuit is in the back of that book. I think there's 10 circuits and this is one of them. So we can see the tone control switch is there. Otherwise I'd have to use the Roto 220. I'm not even sure if it's got a tone thing. So I wanted to try and see if we got that. Otherwise we'd have going to had to put a capacitor tester across what we got if it was writing way on, or if the writing being the other way on. So it's 0.01 microfarads. So 0.01 is 10 nanofarads. So we've got a 10 nanofarad polypropylene capacitor there. It says 103. Yes, that's correct. So 10,000 picofarads. So we need to solder that across the switch. Just like that. Just bend that so the device is like that. So with that information, I've already forgotten which way that switch goes in. Look back at my photo. Black towards the channel selector board. So it's that way in. I just need to attend to something else. Right, so another screw pinched off a scrap set. I'll never find it on the floor. Tighten those up. Make sure there's no marks on the display, because there were. Put the shrouds back. So I'm not going to put the capacitors back. I'll just put a couple of screws in there for now and no knobs, just to make sure that the tone control is working. So that will be something like an hour and 20 minutes on demodifying that. Right. Microphone. Switch on. And it's the wrong way around. Now, how can that be? Answers on a postcard, please. So there's the one we've done. Black wire towards the display board. And black wire black wire towards the display board. How can that be? So I meticulously checked which way the capacitor was and which way the wiring was. I still find it strange, but there you go, these things happen. It's either going to be a long video or a lot of editing video. Mic back in. Good. I'll put the knobs back on, it'll make it easy and we'll worry about the other screws later. Let's go through the transmitter. So now everything's been on for hours. We can set the frequency properly. We're still on the signal, we're still on the frequency counter. Right, they've altered something because it's not actually going on frequency correctly. So it's virtually a channel out. It's 80135 there, and it should be 79125. So we've got to get our thinking caps on as to what else they've done. crystal's definitely 10.24. I bet there's a capacitor missing. Just get a scrap set out. For a start, capacitor 1's missing. Capacitor 1, 2, 3's missing. Right, capacitor 1, 2, 3, both missing. Look at another one. Capacitor 1, 2, 3. So what I'll try and do is get them off this scrap set. Right, see whether we can get that in. Make sure I can get it in from this side. I can. So I will try and get it in from the proper side. So that's one. That should just pull out. It looks like it's unsoldered. Check we can get it in from the naughty side. No, it's not the right place. It would be easier with a new part, but I don't want to charge him. Right, I'll just check at my scrap set. So we've got resistor 120, capacitor 123 back, and capacitor 1 back. Capacitor 1, capacitor 123. I can't see anything else missing that shouldn't be there. No, it's not going to be accurate because it's still going to be cooling down, but at least we can see if we're heading in the right direction and it isn't a channel out. So we're still on channel 20. 2779312 still is not right. So it still needs, there's still something not right. It's just not quite there. Not far out. I'm going to pause the video. Right, let's have another look. So I've put capacitor 3 in. So we did capacitor 1, 56 picofarads. We did capacitor 123, wherever that is. Don't need to find it. But it also shows capacitor 3 with a asterisk. So I don't know whether it's an option or fitted in some or select on test. But it goes there, and it was missing on my scrap chassis, which it may be that it just wasn't fitted, or it may be that it's been borrowed. So let's have another look at the frequency counter. Now we've put 22 picofarad brand new part in. 2779072. So hopefully that will now pull up. We'll leave it there. So, what I put 863 there, didn't I? C1, C3, C123. Frequency. Right. So now 2779125. Now it's cooling down. It's gone right. And let's now deal with this. We'll do the I can't speak. Let's do the VCO. Because chances are that's been faffed with. These are a play toy, aren't they, for some people? Okay, so that should be 4. And on transmit, it should be 4. Receive 4, transmit 4. So it was, what was it, 4.5 plus 3.5, it's now 4 plus 4. Let's go to channel 1 just to verify. So it's somewhere like 1.2, no, 1.8 to 2.3, somewhere like that. 2.1, 2.28, that's fine. So we shouldn't be having any channels dropping out. That wasn't really out. I don't think that has been messed with. It's just gone off with age. So we need to tune the transmitter up. So we'll go back to the normal meter. I've got another task to do, so I'm going to have to disappear off before finishing this again. So we were running this at 12.8 volts. So we're going to carry on for a moment running it at that while I just tune this bit of it. Let's just go on to full power, because that's low power. I'm still at 12.5 volts and it's doing nearly 5 watts. But I need to centralise where we are. We're on channel 20, aren't we? No, we're on channel 1. No wonder it's doing bizarre things. It's 4.5 watts at the moment. To be honest, before I do that, I need to write down what it's actually doing. So I'm going to have to key it up at full voltage. And on channel 20, it's doing 5.3 watts. On channel 40, it's doing 5.2 watts. And on channel 1, it's doing 5.4 watts. I don't look at it on the spectrum analyzer. It's doing a transmit current on channel 20 of 1.493. Right. So I'm going to drop the voltage on the power supply to 12.8 because I don't have it that high for more than about 8 seconds. And we'll go through this. So we're now at we're now at 4.4 watts. We've lost the watt by turning the voltage down. We'll peak that. I need it in the centre. That's the central position. And that one. There we go. Let's hope they haven't melted the cores. So we've got to now, we're going to have to go to full power. Peak. It already was at peak. Surprise, surprise. Peak. Not quite right. And peak. Yeah. So now we go through the proper procedure. So they had left it in the kind of service position. Absolutely bonkers. So we need to drop this to 4.4 watts by turning the yellow one clockwise, and we need to turn this, the manual says 3.8 watts, but we're entitled to 4 watts and we're jolly well having it, so that's now 4 watts on channel 20. That was anti-clockwise. Hopefully it balances. We're on channel 40, let's have a look. It's 4.000 something, and on channel 1 it's 4 dead on, so it's 4 throughout. And our current consumption now is 1.03 amps. It's nice and efficient. Now we did a temporary check on the low power switch, so we'll go back to low power, go to the lower scale, and it's now doing 1.4 watts. Now we've reset the PA. Of course that was going to alter. So it was 400 milliwatts. That deity preset, the RF meter, wrong one, is 5. I mean, what I could, I bet it was full scale deflection before, and we'll just turn that to read 4, which it now is. Oh, I bet they were really proud it was banging across. Surprised the meter still works. It was so loud your meter's gone round twice. let's have a look at deviation, first of all on this test set, and then verify it with the one behind. Wallow. Well, that's showing is wallow 1.4. So I won't adjust it. I've just adjusted the AGC, but we'll just check it with the test set behind in case the Marconi one's lying today, like it sometimes does, but not always. Right, let's have a look. Voila. Yeah, it's quite low actually, it's 2. It's quite low considering everything else has been ramped up. Voila. Now it's peaking at 2.5. Well, at least they weren't transmitting on 3 channels at once. Whilst this radio is presented to me this way on, I'll put the couple of screws in here. I haven't forgotten I need to solder those decoupling capacitors back. So let's see what the deviation says on the Marconi test set. Voila, yeah, it's lying today, so it's 1.6. So it was 2. It's now 2.2 to 2.5 kilohertz peak. So there we go. Super duper. Let's look at this receiver. So we need to set the signal generator, which will be not where it was when I left it this morning. So I now put 100 microvolts on the signal generator. Let's look at it on the oscilloscope. Pretty well spot on that. So we'll go over to the cyanide meter, just see whether we can get a few more dog biscuits out of it. Turn that down there so that it's not saturating the receiver. Well, that was a massive difference to change scales. I love it how they're clever enough to make it work between channels illegally, but they're not clever enough to improve the receiver to how it should be. So we'll put a bit more signal on for the IFs, the intermediate frequencies. That's the wrong tool. That's near enough. And you don't get the extra circuit on these. And you don't get, of course, the extra circuit. So the IFs were right. It was really just that. So let's get a new reading. Set to 12 dB. We've now got... Wow. I'm in the right scale. I am. It was already good, wasn't it? I've now got 0.2. Now, because I'm in between scales, I'm getting kind of the same figure. It's the way the test set is this. So it's probably a little tiny bit less than that, but it doesn't matter. 0.2 is what we'll write down. And for 20 dB, 0.54. Now, before, Scratchy Corner was... Scratchy Corner? We're not there yet. Before, Squelch was spot on, but of course I've retuned the receiver and done the frequency thing. So... yeah, he's now too sensitive. So we'll strengthen that up a bit. So that's now 100 microvolts. So it looks like I haven't done anything, because it's the same as before, but of course the whole thing's been redone. And the sensitivity, let's have a look at squelch sensitivity. Set threshold on the radio, signal generator back on. .48, it's exactly as it was. Right, that leaves us with the S meter, which was a very naughty 420. So now, without any recalibration, it's 155. So we'll now recalibrate it so it's S9 for 100 microvolts. Just like that. And that's it. We're done. Now I'm going to leave this set on. What I'm going to do, we'll just put the final 2 screws in here, just so I can put the bottom on, because that can affect frequency. Never over tighten these, you end up with a ruined fascia. Make sure they're just snug. Put a couple of screws loosely so it doesn't wander around the bench. So, nicely restored to standard. So that's now on my speaker on the wall. We'll turn the signal generator off, turn the squelch up, put an aerial on it. I'm going to come back in an hour just to make sure it's all stable. And we'll finish our video there, but we'll leave it on channel 19 so I can hear them swearing throughout the house. No, you bloody can't. Yes, you bloody can. One Nana Roger. Did someone say Roger to me then? What's your 20 breaker? Roger, thank you. Got me Tango 21 at at Ancaster. That was Boston, 28 miles away. Right, okay. Well, that doesn't often happen, does it? Tend to be farmers on 28. That is the best receiving York 861 I've ever seen. Well, we have a few good Cybernet sets recently. I mean, I've got a Rotel 240 here, and it doesn't do better than 1 microvolt, but it isn't faulty. It's just tolerance, isn't it? But this 0.2, absolutely super duper. I'll just come back. We'll just check the frequency, and then Bob's your uncle. Right, so to put this set to bed, all we need to do is find where I've hidden the lid. There we go. I think we'll be doing the on-the-air test with this first, then we'll do the double test with the emergency set. So Mr. Chippy's got some miles to drive this evening to do a triple test. And I'm so glad it's worked out as such a good set in the end. I do have to just check the mic that came with it, but we'll do that on the air test. And then I'll take these two sets over personally to the intermediary so Alan gets them back. I don't even know if he's in the town that we're actually going to, but it doesn't matter. Really appreciate what Alan does for us. Let's put it on its own speaker and have another flick round. 19 Roger. He can get one. Just coming up to 5 o'clock. Alright, there we go. Proudly says made in Japan on it as well. Good. Thanks for watching the York 861 and set that from 1981 uses the Cybernet 134 chassis.